This video presents the Chapter 1, Part 1 of the course Logic Design of Switching Circuits. In this first section, I show counting system using bases: decimal, binary, octal, and hexadecimal. Definitions of byte, bit, nibble, and word. In this section is presented the counting systems for the base 10, binary, octal, and hexadecimal. Such counting systems are shown using a table which lists the number from 0 until 17 in the aforementioned bases. Initially, to the base 10, observe that the rightmost digit has the value of base raised to the power of 0. The next leftmost digit has the value of a base raised to the exponent 1, a 10 value. Thus the base starts counting using the rightmost digit, count from 0 to 9, using the 10 digits of the base 10. When the base capacity is exhausted, the next digit starts its count, with the count number 1 that goes from 10 to 17. For binary base, the same process is used. First, the rightmost digit that has the value of a base raised to the power of 0 starts the count. When the count of this digit is exhausted, the next leftmost digit begins to the count. When this digit is also exhausted, the next leftmost that has the value of a base raised to the exponent of 2 starts the count. The process continues to the left, with each digit representing the value of the base raised to the power with a 1 added to the value of the power of the anterior digit. Note that each base has a different number of digits equal to the base number. The base binary has only 2 digits, 0 and 1. For the octal base, the same process is used. This base has 8 different numbers or digits, from 0 until 7. For hexadecimal base are needed 16 digits. Thus it was agreed that the letters A, B, C, D, E, and F replace the numerals 10, 11, 12, 13, 14, and 15. First, the base exhausts the counting capacity for the rightmost digit, counting from 0 to 15, and then begins to use the leftmost digit using the value 1, which has the value of the base raised to exponent 1. That is, the value is 16. This section presents the definition of a byte, bit, word. A number consisting of 8 binary digits is called a byte. This number can represent the numbers in decimal base from 0 until 255, if only positive are represented. If positive numbers and negative numbers are used, one byte may be represented numbers positive from 0 until 127, and numbers negative from -1 to -108. Also, a byte can represent any number, letter, or special symbol according to the standardization table, American Standard Code for Information Interchange, ASCII table. Each binary digit that makes up a byte is called a bit. The digit of the lowest value, this is the digit localized at the rightmost, is called LSB, less significant bit. The digit that represents the highest value is the byte. This is the digit at the leftmost position is called the most significant bit, MSB. If you divide the byte into 2 parts, with 4 binary digits for each part consists of 4 binary digits and is denominated of Nibble. The two nibbles are called nibble more significant, the most left, and nibble least significant at the right. Structures composed of more than one byte are called word. The word term is generic and doesn't automatically specify the numbers of bytes that compose it. Two examples are presented, one with 2 bytes and another with 3 bytes. Then, it's necessary to specify the length of the word of 16 bits, word of 24 bits. In general, the words are specified using numbers of bits.